Dialogues. I'm Anshika Mishra. Today we'll talk about brain connectivity patterns vary between preterm and term infants. A new study from King's College London reveals unique pattern in the moment-to-moment activity and connectivity of brain networks between term and preterm infants after scanning 390 babies. The study, published in Nature Communications, revealed that these dynamic brain connectivity patterns in infants were associated with developmental milestones such as movement, language, cognition, and social behavior 18 months later. Although we know how influential brain connectivity is on development, we know little about the pattern of dynamic functional connectivity in early life and how they link to the way our brains mature. By analyzing brain scans from 390 babies, we have begun to identify different transient states of connectivity that could potentially provide insight into how the brain is developing at this age and what behaviors and functions these patterns are linked to as the baby grows older, said Dr Dafnis Batallé, Senior Lecturer in Neurodevelopmental Science at the Institute of Psychiatry, Psychology and Neuroscience, King's College London.
Are you also aspiring to excel in medical journalism and delve into the intricacies of health and medical reporting? Explore our comprehensive course on medical and health journalism available at the Medical Dialogues Academy. Learn from industry experts who possess in-depth knowledge and experience in this field. For further details, scan the QR code provided or access the link in the description box below.
Researchers employed advanced technique to analyze functional magnetic resonance imaging, which is the fMRI data from 324 full-term infants and 66 preterm infants born before 37-week gestation. They evaluated the moment-to-moment changes and connectivity during the time the baby was in the scanner, offering a dynamic perspective. The study utilized different methods to analyze fluctuating brain connectivity, one assessing patterns across the entire brain and another focusing on regional patterns. 6 distinct brain states were identified, with 3 encompassing the whole brain and 3 restricted to specific regions, that is occipital, sensorimotor and frontal. Comparison between term and preterm infants indicated that varied connectivity patterns were associated with preterm birth. For instance, preterm infants exhibited increased time spent in frontal and occipital brain states compared to the term infants. This is a real step forward in the use of imaging techniques to investigate how brain activity is continually changing in early life and how this provides a platform to support subsequent developmental milestones in childhood. The difference between term and preterm babies suggests that time spent in or outside the womb shapes brain development. We now need to try and find out if it is possible to use these insights to identify and help those who need some additional support, concluded Professor Grainne McAlonan, Interim Director of NIHR, Maudsley BRC and Professor of Translation Neurosciences. Thank you for watching. Stay tuned to Medical Dialogues for more updates.
Never miss a medical update from Medical Dialogues. Like, subscribe, and press the bell icon.